Hello, my name is John Bigham. I'm a member of the Product Management Group working with the MapObjects-Java product here at ESRI in Redlands, California. I'd like to welcome everyone to today's presentation titled Introduction to MapObjects-Java Edition. Before we begin, I'd like to go over some of the topics included in today's presentation. First of all, I'll be presenting some of the features and functionality available in MapObjects-Java. I'll also discuss various deployment options for once you have finished developing an application. Finally, I'll give an overview of the extensive documentation that comes with the product. We'll also have several software demonstrations throughout the presentation. Now I'll present some of the features and functionality available in MapObjects-Java. However, before discussing MapObject specifics, I'd like to talk about the Java environment in general. Java is known for its write once, run anywhere capabilities. This allows you to compile your program on any platform that has a Java compiler. The program can then be translated and run on any operating system with a Java virtual machine. Java has also set new standards for Internet deployments. Using Java 2 Standard Edition, you're able to create standalone or browser-based client applications. Using Java 2 Enterprise Edition, you're able to develop server-side applications as well as write applications for consumer devices. The Java community process, it's an open organization of international developers that create and revise Java specifications. Through such large active participation, it helps foster security and standards. You can visit www.jcp.org for further information. Now it's important to note that MapObjects-Java adheres to these Java standards and works well within both the J2SE and J2EE environments. Well, what is MapObjects-Java? It's a toolkit for Java developers, and you have the ability to build client or server-side, cross-platform, GIS and mapping applications. And MapObjects can be used independently of all other ESRI software. You're not required to have other ESRI products for complete functionality. However, it does have the ability to interoperate with some ESRI products for a complete enterprise solution. And the toolkit contains embeddable mapping components to create your applications. These components expose a 100% pure Java application programming interface that's distributed within jar files. As you know, the Java archive file format enables you to bundle multiple files into a single compressed file. To help further describe MapObjects, let's consider this diagram here. At the top left, we have MapObjects components represented by the blue circles. Underneath that, there are red and orange circles representing various other Java components. These could be Java Swing components or any other freely downloadable Java components that may satisfy other business needs. On the right, this box symbolizes the framework where you plan to build your application. You could start your application from scratch, or you may already have a working Java application, shown here by the yellow circles. And you may need to embed mapping functionality into it. Either way, MapObjects can provide a solution. Now we've added several blue circles and several red and orange circles representing the various other Java components. Everything has been seamlessly integrated into a single application at this point. As your application grows or becomes more streamlined, components can be added or removed as well. Notice that the yellow circles representing the pre-existing application are also incorporated in the new application. When the application is complete, the final result may appear similar to the application seen here. It could be accessible through a web browser, or built into a standalone desktop application, or it may be an application running on the server that doesn't require a user interface. As a developer, it's up to you what functionality will be available, if and what user interface will drive that application, and the means to deliver it to the end user. With that concept in mind, let's look at some other general reasons why you might develop with MapObjects. First of all, it's completely customizable. You customize the end user's experience. You can narrow or broaden the scope of the application to fit their needs. And it doesn't have to be the centerpiece of an application. It can easily be embedded into existing Java applications. However, it can definitely be the starting point for a Java-based mapping application. Because MapObjects is a pure Java API, it's fully cross-platform. You choose the system to develop with and the system to deploy to, such as Windows, Macintosh, Red Hat Linux, Sun Solaris, or any of the others listed here. You can refer to the MapObjects-Java product pages for all the latest technical specifications. You can also take advantage of the various web deployment capabilities that Java offers. We'll be examining specific deployment scenarios later in the presentation. And standard GIS data formats are all valid data sources. This image here shows that you can access ESRI's Geography Network, which is a repository of published web services all around the world. We'll discuss other valid formats later on as well. I'm now going to demonstrate JoView Plus. This is a fully functional sample application created using only MapObjects-Java components. It showcases some of the more important features of MapObjects as a comprehensive GIS application. JoView Plus can be started immediately after installation, and the complete source code is provided. As a result, it's completely customizable. Let's go ahead and take a look at it now. Here's the main JoView Plus interface. On the left we have the table of contents area, and on the right we have the map area. At the top we have the toolbars. We also have the menu options here. Now, everything you see here and other components we'll bring up are completely customizable. You can add or remove entire toolbars. You can create dockable toolbars. You can change icons. You can add or remove functionality. You're provided with the building blocks to create a unique application. I'll go ahead and do a short demonstration here. Now this is the Content Chooser component. This allows your end user to select data for their project. And you're able to determine which contents you want to show. Perhaps you only want to show layers or images or some custom type layer you've created. And it helps you navigate to all the different data sources. Now I'm going to go ahead and select a layer to add to the project. As you can see, the layers now appeared. We also have another tool. It's known as the catalog component. And this gives you a way to browse for data as well, but allow you to preview and do a little bit more. I also want to note that you're able to add internet map services. You're also able to add spatial database connections. But for now, we're going to navigate to some local files. Now you can see the contents have shown up here on the right. We also have the ability to preview this data. And it's an interactive preview, so we can zoom or pan as necessary. We can also take a look at the attribute table for this shapefile. And there's all the listed attributes. I also want to note that you can also select various types of data formats, and it'll identify which type they are. So now that we've decided on a layer, we also have the ability to drag and drop this layer into our application. Go ahead and close this dialog now. And you can see the country layer is now showing. Now within the table of contents, we have the ability to turn on and off layers. We also have the ability to move layers around. We can also show the symbology or choose to take it away. Now I'm going to set a projection for this data. So I wanted to mention you have the ability to create custom projections, and you could enter the coordinates here in this tab. But for now we're going to go ahead and choose a world projection. Go ahead and apply this. And you can see the projection is now shown on the map interface. So we'll go ahead and zoom in on an area. Another tool you have is the select tool. You can go ahead and select layers and they appear highlighted there. We also have a buffer tool. And let's say you want to create a buffer around the selected countries. You can go ahead and do that. And as you can see, the buffer appears in the pink area around the highlighted countries. I'm going to go ahead and clear that selection. You also have the ability to do finds or identifies. You can also take measurements. I'll go ahead and calculate one. And you can see the results there, and this takes into account the projection applied. I'll go ahead and clear that off. Now I'm going to change the layer properties for this country layer. And this layer properties dialog you see here helps determine what color you want to show the layer in, if you want to show labels or not, and the type of symbology. I'm going to choose a graduated symbology. I can also choose the colors. I also want to show some labels. So I'm going to choose to show labels for the name of the country. And I can increase their size and change various effects here. I'm going to go ahead and apply these to the map. And as you can see, the colors and labels are now applied to the map. And also note that in the table of contents, the new colors are applied in the country layer. Nice thing, when I open back the layer properties back up, the settings I had previously are still there, so I can easily adjust them. For example, if I wanted to take the labels off, we'll apply that change, and the labels have disappeared. Another feature of JoView Plus is the layout view. And here you can see the map component, and this allows us to create cartographic layouts using various elements. First of all, I'm going to go ahead and add a legend to this map. I can also add a north arrow. This north arrow dialog is customizable, or you could have various true type fonts in here. You have a north arrow. You can also add various graphic elements to help the design of your layout. It's important to note that within the layout, the map is still interactive. You can zoom or pan identify within the map component without having to switch back to the map view. The table of contents is still interactive as well. I can turn the layer on, or I can turn the layer off. Finally, I want to show you the ability to save this project. I've saved this as an ArcXML project file, and you can see the project listing at the top. Now this will allow the layout settings to be saved. It'll save the map view settings, and so the next time I open it back up, I don't have to start over again. Now I want to discuss and further expand upon some of the features you saw in JoView+. You saw us use Shapefiles as one of the data sources. Well, there's numerous other sources you can use as well. You could use ArcSDE layers. And ArcSDE is a gateway that facilitates managing spatial data in a database management system. It allows you to manage the geographic information in many popular databases. ArcIMS services are also valid layers, and ArcIMS is ESRI's solution for distributing mapping and GIS data and services on the web. It also accepts various military formats, CAD data, smart data compression, and image formats such as JPEG and TIFF. MapObjects comes with the ESRI Data and Maps Media Kit with various sample data in these formats to try out yourself. And note that you can also extend the MapObjects API through the plugin to architecture to read your own custom data sources. Complex spatial and attribute queries can be performed. The image here shows the Query Builder user interface for completing attribute queries. The dialog and interface can be customized to your needs. Spatial queries can be done with various selection tools that you saw in JoView+. And once an area of the map is selected, the buffer calculation can be made. And shown here is the buffer UI. Like the other components, it's also customizable and can be used to determine features within a set distance of a selection. Other spatial operations such as union and intersect can also be calculated using the MapObjects API. In fact, there's over 30 types of spatial operations that can be used. If you're unfamiliar with any of these terms, I recommend visiting www.gis.com for more general information regarding GIS. You saw how a projection could be applied to a map using the projection UI. But this UI can also be manipulated as necessary. Perhaps you only want to include a few projection types, or you want to provide extra features. You also have the ability to create your own custom projections and display them within this UI. I briefly showed you the layout capabilities in MapObjects. Legends, graphic elements, overview maps, and images can all be inserted into a layout as well. And as I showed you, the map element still remains active, so you can perform zooms or pans or identifies without having to go back to the map view. MapObjects also allows map compositions to be applied to a variety of printer sizes. And all the settings within your project, such as the layer properties, the projections, the zoomed location, or the presentation and layout can be saved and reopened again at a later time. These project workspaces are saved as ArcXML files, also known as Axle files. Now ArcXML is ESRI's version of the XML, or the Extensible Markup Language format. And the customizable UIs we just discussed contribute to rapid application development. This means that programmers can quickly build working, reusable programs. You have the ability to produce a stable, final application in a relatively short amount of time. In general, these high-level components provide a number of tools to help build graphical user interfaces that would normally take a large development effort. To further aid development, MapObjects provides a suite of JavaBeans. JavaBeans, of course, consist of predefined functionality and code in the form of reusable software components, which can be manipulated visually in a builder tool. This allows for easy drag and drop development within various IDEs. And you have the ability to develop with standard IDEs such as Borland's JBuilder, Sun1 Studio, Oracle's JDeveloper, and others such as NetBeans. There are also many open source, freely downloadable IDEs as well. And to show how this works, we'll now do a short demonstration utilizing the JavaBeans within JBuilder to create a simple application. We'll be able to do this without writing a single line of code and using only the JavaBeans. This here is the main JBuilder user interface. Now I've resized it and I've closed many of the dialogues and deleted many of the toolbars to better show you the design frame. Here we have the various visual tools that you can use to build upon this design frame. There's swing components such as adding labels or text, and there's swing containers to add tab panes. We also created, prior to this, a Map Objects tab, and on this tab we loaded all the visual JavaBeans that we provide. As you can see, there's various toolbar JavaBeans, there's a map component, table of contents component, a scale bar. Now we're not going to be using all these today, but just a few to give you an idea of how it works. So to start building our application, first I'm going to use a Java swing container. And this is a Java split pane component. I'm going to go ahead and add this to the frame. And as you can see, it split the frame into a left side and a right side. And this is handy when you want to make a map in a table of contents. So now I'm going to go ahead and add a table of contents component. And you can see it appeared there. I also am going to now add a map component. And now, to make sure the table of contents component works with our map component, we need to set the map property for it. And that's done in the Properties panel here on the right. And this basically tells it that it's working for this map component here. And we also need some type of interaction for our map. So I'm going to add a zoom pan toolbar. And that'll give us the ability to zoom or pan around our map once we've added data. I also need to set the map property to tell it which map to communicate with as well. Finally, we need to add a layer. We need to have a map layer that's going to appear in our map. That's what this layer bean's for. So I've went ahead and added this to our map. Now I need to set which specific data set this map layer is going to show. So I can do this using the dataset property. And here you see the content chooser, the same one that was used in Jovi Plus, where we can navigate to some data. We could choose map services or spatial database connections as well for this. But for now, we're going to navigate to a local data. And I'm going to go ahead and choose a CAD data set. So, that layer now has a specific data set for it. And we also could add several layers if we wanted, but for now we're just going to use one. Before we start run our application, I want to take a look at the source code. All this source code was created just by using our visual JavaBeans. As you can see, it's quite a bit of code in a relatively short amount of time. It set all the properties without us having to type anything in. Now I'm going to go ahead and run this application to see what it looks like. It's going to go ahead and compile, and it'll come up in just a minute. So here's our application. You see the CAD data set, and we're able to easily zoom in. We can turn the layer off, or turn it back on, and we can pan And all this was created within a relatively short amount of time. MapObjects-Java is a toolkit for Java developers to build cross-platform, GIS, client-side, and server-side applications. It's also scalable, task-focused, and web-friendly. You control the end-user's experience. Some of the features that we showed you earlier include support for projections, numerous data sources, and layouts. The customizable user interface dialogues in JavaBeans are provided to help you quickly get started. Now that we're familiar with how applications are created and the features available, we can discuss deployment options for completed applications. First, we'll discuss client-side deployment possibilities. Applications can be distributed using the traditional CD or DVD. This is useful when providing large data sets to accompany your application. You also have the ability to include a private JRE or Java runtime environment on the media to avoid possible conflicts with other JREs already on the system. This would be useful if the users don't have access to the internet or are new to computers in general. You may also choose to deploy through the web by using an applet. As you know, applets are applications that take up real estate within a web browser. After the initial applet is created in the browser, all subsequent work requests from the client take place within the browser. These requests are fulfilled by MapObjects-Java components that are hosted on a web server. Whenever the MapObjects components are updated, the latest version is automatically made available in the applet. Another option is deploy with Sun's Java Web Start utility. Java Web Start is a standard launching mechanism for distributing client-side Java applications over the web. Web Start gives you the ability to launch robust, full-featured applications with a single click from a web browser, while still maintaining the Java security standards. The first time the application is accessed, the necessary files are downloaded to the client's machine. Those files are then cached on the machine so that the application can then be launched anytime directly from the computer, even offline. And MapObjects-Java can utilize any of these deployment methods. We'll now have a brief demonstration of an application deployed with Java Web Start. This application here was accessed through a web browser initially, and it was brought up in an independent window. It was created using freely downloadable Java charting components combined with MapObjects toolbars and the map interface. It's actually connecting to the geography network to obtain the maps and data. And as you can see here, the application is showing in the red, it's showing the temperature in Fahrenheit, and the blue levels are showing the rainfall. And as I navigate through the map, the various locations are recorded, and the temperature and rainfall adjust accordingly. Now, this application is being used for climate studies, but could easily be customized for other industries, perhaps showing crime rates, or flood risk, or demographics, or others. Since MapObjects can also be used for server-side deployments, I'd like to discuss some of the general server-side possibilities that Java provides. After that, we'll take a look at exactly how MapObjects fits into the server side. Servlets extend and enhance the functionality of web servers and can access existing business systems. They're server and platform independent. They generate custom HTML pages and maintain unique session information for each client. Servlets are often used to produce dynamic content for display in JSP pages or Java server pages. Now, JSPs separate the user interface or the presentation logic from the content generation, or the business logic. The business logic can reside in server-based resources, such as enterprise JavaBeans, and these are accessed using servlets. EJBs are sets of reusable software components on the server side to handle the needs of transactional business applications. EJBs can take advantage of time-tested, industry-standard application servers such as BEA WebLogic, IBM WebSphere, or JBoss. And these application servers also implement the latest standards in web services. Web services consist of XML communication between different environments. Keep in mind that these server-side options are all governed and specified by the Java 2 Enterprise Edition standards. Now, the first server-side scenario using MapObjects is utilizing MapObjects components on the web tier to create custom servlets and/or Java server pages. And these can be accessed by various clients, such as a distributed application, or from a web browser, or from a mobile device. You can also build MapObjects components into EJBs to use within an application server. These MapObjects EJBs will then handle your GIS functionality. Note that one or more different EJBs can be created to each handle specific functionality. As the diagram shows, the EJBs are also normally used to communicate with other relational database systems. When the various databases are part of the application architecture, they'll usually fall within an Enterprise Information System tier. This tier is the Enterprise Information System infrastructure. Databases make up a key component of an EIS, but this is also where your existing legacy applications or related web applications can reside. In summary, there isn't one particular path through the tiers that must be followed for any application. Therefore, it's not necessary to have a servlet from the web tier work with the MapObjects EJB to access a database. It has the ability to directly access the database itself, bypassing any use of the EJBs. You could also have a MapObjects client application that retrieves services, yet it still makes calls to a database through the web and EJB tiers. Now we'll see some brief demonstrations of a browser application utilizing MapObjects EJBs to perform the work. We'll also see an example of MapObjects at the web tier delivering dynamic content on a JSP to a mobile device. This is a web-based Java server page. Let me go ahead and bring that up. Now, this page is sending a request to a servlet on the web tier that calls upon an EJB to process the results. After the request is completed, the result is then returned to the JSP. And this is created using the server map package that allows for these various operations to be completed. So I'm going to go ahead and zoom in here. And this allows us to select features. We'll go ahead and select some countries. And you can see they're highlighted and the attributes are shown below. Each time I make a request, that request is sent to the servlet, which in turn passes it on to the EJB, and the EJB sends the results back. We can also choose which layers are visible and which layers are active. We'll go ahead and refresh the map. You can also identify countries or areas. Go ahead and clear that selection. We also can perform a find calculation. And as you can see, Germany has been highlighted and the attributes are shown below. Now this could also work in other web browsers as well. And you could also create similar output using only a JSP with a web server, or using a servlet to handle the workload without any EJBs and return the results to the JSP. The result would appear the same to the client either way, although there are major differences on the server side. Now I'd like to show an example suited for a mobile device. Here we have a mobile phone emulator. And perhaps you wanted to create a similar application, but you didn't need all the functionality of the EJB server, and your clients had these mobile phones and not web browsers. Well, you could use the MapObjects components to create an application to be used within a mobile phone device. The following screenshot shows JSPs being consumed by a mobile phone using WAP, or the Wireless Application Protocol. And these were created using the OpenWave emulator to mimic the phone interface on the computer. The client can choose a map to display. They can choose which data layers they would like to see. Then the selected map will be shown that you see here. These images are black and white since they are following the WAP 1.0 specifications. A couple more view of the maps here. Now we'll see the full color capabilities using the WAP 2.0 specifications. The same type of application is created here, but a slightly different phone interface for the selecting the data layers is shown. Now a full color map of the US is shown here. We can also zoom in, and you can see it's zoomed to the northeast US now. And to navigate these maps on the mobile phone, the keypad is used. The key sequence properties must be downloaded to the device prior to accessing such a service. Once installed, the zooms and pans are controlled by pressing a particular key. For example, number 2 may pan north, or number 5 may zoom in. Just another view of the map here. Now we'll see an active demo similar to the mobile phone screenshots, except using a web browser as the client instead. And this simple JSP page allows us to select a map, now we can also select the properties just as you saw in the mobile phone screenshots. We can set the size of the image and which type of color, or gray. Now we'll go ahead and retrieve this map. This page is going to deliver the map of the US. And here you see it. Now I'm going to go ahead and zoom in a little bit. I'll zoom in a little bit more. Now notice the panning and the zooming are controlled through the web browser instead of on the buttons on the keypad. But this should give you an idea of how things would work on the phone. And as we finally bring on the map here, I'll pan down. And there you can see the full map. So hopefully that gives you a good idea of the possibilities when serving to mobile phone devices or to the web browser. Now I'd like to review some of the topics we covered. We saw the use of MapObjects-Java for client-side solutions, such as CD or DVDs, and browser-based applets or Java Web Start. We also saw the various types of server-side deployments using servlets, JSPs, EJBs, and the web services you just saw. I also diagrammed how MapObjects fits within each of the server tiers and the entire application architecture. Now I'd like to discuss some of the product documentation that comes with the product. First of all, you receive the Getting Started with MapObjects-Java. This is a PDF that comes on the CD. And it's really a quick start tutorial with step-by-step instructions for building a simple application using JBuilder, Sun1 Studio, and the Java 2 SDK. It's really a great starting point for someone new to the product. You also receive the MapObjects-Java Developer's Guide. And this book provides comprehensive coverage of the core classes and interfaces. It provides further description of server-side and client-side possibilities, and it also takes you through customizing and extending the MapObjects API. You also receive a class diagram poster. And this UML diagram is included in large hard copy format, as well as a PDF on the CD. This diagram is really your roadmap to the API. Finally, you receive the web help. And the web help is digital documentation that comes on the CD. And it includes the JavaDoc. And the JavaDoc, of course, has your standard interface and class descriptions, as well as detailed UML diagrams by package. The web help also contains various information resources, such as details of new features in version 2.0, a conceptual overview of the MapObjects API, various helpful utilities, and it's really your one-stop guide to all the documentation and samples on the CD. Some of those sample applications are these, the server samples, JSPs, servlets, and EJBs. And you receive step-by-step instructions for JBoss, IBM WebSphere, Apache Tomcat, BEA WebLogic, Sun1 Application Server, and New Atlanta Serverlet Exec to quickly build working applications. There's also JavaDoc included for these samples. You see JoView Plus. It's a comprehensive, full-featured sample application built with MapObjects components that was demoed earlier in the presentation. Now remember, that's completely customizable when you receive the source code for it. Finally, receive the tutorial application. And this is an extensive guide for feature-specific instruction. And I'd like to go ahead and demo this tutorial briefly right now. This is the main tutorial book interface. And note that this interface has been resized for presentation purposes. It's actually meant to be viewed at full screen to easily read the contents and view the demo portion. Over here on the left we have the contents. In each of these topics there's also subtopics underneath them. And we can open up and collapse these topics as necessary. And they're grouped together for similar functionality. We also have a tab that we use for the text, and this gives us just description of the sample, and it also tells how the sample works. It shows the key parts of the source code and explains each of them. It also just lists some of the key classes involved. On the right is the demo portion. Now this is an interactive demo, and we'll show you some examples of that in just a minute. And there's also a tab for the source code. Now here you can see all the source code for the entire sample. So you could copy and paste this into your application, or you might just review it. Now I want to show you a couple specific samples. So we discussed the query builder earlier, but we never actually showed it. So here's the query builder interface. I'm going to go ahead and open up a query builder, and we'll just do a small short query. So we're trying to find Colorado. We're going to execute that, and there's the result below. I'm going to choose to highlight that result. I'm going to close out the query builder dialog, And there you can see the result is highlighted. Well, what's going on here? This is what the text is for. We have the description above. We also show how it's working below. And if you just need to copy all the source code, you could go ahead into the source code tab and copy it as needed. I'm going to go ahead and close this topic and open up another topic. Switch to the demo view. And this is another demo showing you how you can track moving objects. So go ahead and start running this application. As you can see, the balloon is moving around the map. We also provide the complete source code for this sample as well. And the text will give you a good idea of what's going on and exactly how to manipulate it. Now we'll do a short review of some of the programmer resources in the sample applications. We received the Getting Started Guide, the MapObjects-Java Developers Guide, the UML class diagram poster, and the web help, which contains the Java doc and other information resources. You'll also receive the sample applications that supplement this documentation, the server samples, Jovie Plus, and the tutorial. And for more information, there are several places to turn. There's a 3-day instructor-led training course offered in various locations. That's Programming MapObjects-Java Edition. You can refer to the instructor-led training area on esri.com for dates and locations. Also, the product pages contain a wealth of information to review. There's also a link to the evaluation copy included on the product pages. And this is a freely downloadable 90-day full evaluation version available for each of the supported platforms. And this will contain many of the samples and documentation we discussed earlier. Finally, you can visit www.gis.com for more information regarding general GIS concepts. Well, on behalf of ESRI, I hope you enjoyed the presentation, and I want to thank you for listening. Have a great day.